Hello and welcome back. In this video, we're going to expand a little bit on vectors in physics. What if a car travels 11 meters at 65 degrees north of east, but you also want to find out how far east and how far north the car drove? These have a particular name in math called component vectors, the projections of a vector along the axis of a coordinate system. Going back to the physics, if the car has a displacement of 11 meters at 65 degrees north of east, it also has a displacement in the x direction, delta x, and displacement in the y direction, delta y. Delta x and delta y are the component vectors, which have single directions only. What's the actual question to this diagram? A car travels 11 meters at 65 degrees north of east. What are the x and y component vectors? Just to be aware, the question could be phrased differently. A car travels 11 meters at 65 degrees north of east. What is the horizontal and vertical displacement? Even though the wording is different, it's asking for the same thing, which are the component vectors. So, how do we find out the component vectors, delta x and delta y? With the vectors drawn in, you notice that we have a right triangle formation. Since the hypotenuse and one of the angles are known, to find delta x and delta y, we'll have to use a couple of trig functions, cosine and sine. I'll start with cosine. Cosine of the angle is equal to the adjacent side over the hypotenuse. Based off our diagram, it will be cosine of the angle equals to delta x over d. Let's plug in the displacement and angle, and we can solve for delta x by multiplying 11 by cosine of 65 degrees. Delta x is going to be 4.65 meters east. Remember, the car traveled north of east, but since we're solving for delta x, which is the x component vector, we attached east as it is the x direction for this problem. To figure out delta y, we'll use sine. Sine of the angle is equal to the opposite over the hypotenuse, which is delta y over d in this case. Plug in and go through with the calculations. 11 by sine of 65, and delta y is 9.96 meters north. Though we know the car moved 11 meters at 65 degrees north of east, what we found in solving this problem is that the car moved 4.65 meters east and 9.96 meters north while doing so. And this is how we calculate for component vectors. Finding component vectors is not exclusive to displacement. This also works for velocity if the object is moving in 2 dimensions. We can find the velocity in the x direction and y direction as long as we know the velocity v and an angle. With that being said, try this one on your own. A bird flew at a velocity of 7 meters per second. At 35 degrees south of west, what are the x and y velocities? Pause the video and resume when you think you have the answer. Alright, this concludes our video on component vectors in physics. Hope you found it helpful, and thanks for watching.